Hello class. Okay, this is a short video instruction on how to do the math for an optimum tariff. First, there's a few assumptions that need to be in place. The first one is that you have a large country, so let's let country 1 be the large one. And large is defined to be large enough so that it can affect the price in country 2. And then the second assumption is that country 2 does not retaliate. If country 2 retaliates, all bets are off. So then in country 1, let's let the demand curve be 2200 minus 2p and the supply curve be 4p minus 200. Then in country 2, we can calculate the excess demand curve. That is, the demand curve that they will see for their product in country 1. And it's defined to be simply the quantity demanded minus the quantity supplied from country 1. So you can see here where I've done the math. I've just substituted here. This is the quantity demanded minus the quantity supplied. You work that out. You get the excess demand curve is 2400 minus 6p. Finally, let's let country 2's export supply curve be 6p minus 180. So this I will have to give you. You don't derive this. This comes from their country. This is their willingness to sell abroad. Alright, now let's imagine we put country 1 on the left and country 2 on the right. Then we have the demand curve. I don't think I've asked you to calculate these endpoints, but you can calculate them. It might help you keep a sense of scale. This number down here at the bottom is going to be 2200. This number up here will be 2200 divided by 2, or 1100. Then we have our supply curve. This intercept over here is going to be 200 minus 4, which is 50. Then we have our equilibrium price, and now I've gone ahead and drawn this equilibrium price all the way over into country 2, and you can see that the excess demand curve starts at the equilibrium from country 1, because really any price above 400, country 2 has no opportunity to sell in country 1. In fact, country 1 would be exporting. So the export demand function, the excess demand function, starts here and runs down, and from the equations that we worked out later, we have this equation right here, 2400 minus 6p. Then we have their supply curve, which I just gave you, 6p minus 180. Now the equilibrium, if there's free trade, is going to come from the excess demand function and their willingness to supply function. So equilibrium will come from here. I've gone ahead and calculated it by just setting quantity supplied equal to quantity demanded over here. That gave me this number of 215. So now there's two ways to figure out how much will be imported. One way is to do it like we did early in the semester. Just find the quantity demanded over here and the quantity supplied, and then you can figure out how much they import. But the other way to do it, and maybe a simpler way, is over here. Since this market represents their trading ability with country 1, we can just get this equilibrium number here, and this number will be equal to the difference between quantity demanded and quantity supplied over here. So here I've gone ahead and worked it out. I've just taken this $215 price, I've set it into the demand equation, and I got this number, 1770. Then I took the 215, set it into the supply equation, and got this number, 660. You can take the difference between the two, and you will find that it's 1110. That is, 1770 minus 660 should be 1110, because what's going on in this graph over here must be consistent with what's going on over here. Go ahead and work out the math and you will see that that's right. Now let's put on the tariff. So this is a simple per unit tariff. It's just going to raise up the excess supply curve by the amount of the tariff, and let's go ahead and let the tariff be $50. So we can figure out now the new supply equation. The hard way is to undo Alfred Marshall's mistake, add $50 to the y-intercept, then put Alfred Marshall's mistake back. Or you can do that sort of shortcut by taking the $50, multiplying it by the coefficient on p, so 50 times 6 is 300, and then subtracting that from the constant term. I lost my mouse. The constant term, subtracting it from that, so minus 180 minus 300 is 480. Then we can calculate our new equilibrium, which will be 240. And now we can, like before, we can calculate how much is imported, just like this, or we can calculate it over here, right? So it turns out now that the amount that's going to be imported is 960, and that will be equal to the difference between quantity demanded and quantity supplied over here. So I just took the 240, stuck it into the demand curve, and I got this number, 1720. Then I took the 240, stuck it into the supply curve, and got this number, 760. And the difference between them is 960. Now the next thing we need to do is consider what's really going on with this tariff. So if you think about this $50, I'm just going to drag that line down here. So this purple line right here represents the $50 because these two things are parallel. So I hope you can see that the $50 tariff didn't get completely passed over to the buyers in country 1. Their price didn't go up by $50. Their price went up, I think, by $25 only. So that means that country 2 absorbed part of the tariff. So you can bring that line over here, just bringing it over, and then we can see, okay, so it's 190. That's easy because we know that number was 240. The tariff was $50, so this number must be 240 minus 50, or 190. Now, this little shaded part right here represents a benefit to country 1 that's really coming from country 2's willingness to absorb part of the tariff. In other words, country 1 is going to get the tariff revenue, which is represented by this big box right here. This box right here, that's the tariff revenue collected. This little piece up here doesn't count as a benefit because it was originally consumer surplus and now it's tax revenue generated, so that's a wash. But this part down here wasn't part of consumer surplus, and now we get that benefit because country 2 has absorbed part of the tax. Now remember that we had these two losses up here before we did the optimum tax. These were called deadweight losses because there was no offsetting gain, and then there is now, of course, this offsetting gain. So it's theoretically possible that this gain can exceed these losses over here, and in this problem you can actually work it out. So the losses are these two little triangles. The area of a triangle is 1/2 the base times the height. So this little triangle right here is 1/2 times 100, because that's this distance, that's the base of the triangle, times 25, that's its height, plus this triangle over here, which is 1/2, its base from here to here is 50, and its height is also 25. So when you work that out, it turns out that the losses are 1875, and now the gains, this little box right here, is the area of a box is just the base times the height. So here's the height right here, 215 minus 190, right? That's this thing, and then its base is 960, which works out to be 24,000. So we have this gain, we have this offsetting loss, and so we have a net gain of 22,125. So I hope you found that helpful, and you should practice by working through that problem on your own a few times. You'll probably see one like this on our next test. See you later.